Hello everyone, welcome back. In this video, we'll be discussing about the last problem of today's weekly contest, maximum strictly increasing cells in a matrix. The problem is a bit interesting, and as always, we will try to start from scratch and build the solution along the way. And I am very sure that if you watch the video till the end, you will be able to understand a lot of things from this video and apply it in all possible future variation of this problem. So with that, let's get started. The problem states that you are given a m cross n matrix and you can select any cell in the matrix as your starting cell. Now from the starting cell, you can move to any other cell in the same row or the same column if the value of the destination cell is strictly greater than the value of the current cell. Now you can repeat the process as many times as possible, and your task is to find the maximum number of cells that you can visit by starting from some cell, right? So let's take an example. Let's say this is the matrix 3134, and you can start from any cell. You can start from 0 comma 0, 0 comma 1, 1 comma 0, and 1 comma 1, right? You are free to start from any cell. Now let's say you start from 0 comma 0, or you start from this particular 3. So it is given that you can transition to any cell in this row or in this column unless the value is actually strictly greater than the value of the current cell. So in this particular case, you can't transition to 1 because value of 1 is smaller than the current cell. Similarly, you can't transition to this 3 as well because value is not greater, it is equals to, right? So if you start from 3, you can't visit to any other cell, and hence number of cells that you are visiting if you start from 3 is 1. Similarly, let's say you start from 1. If you start from 1, you can visit to 3 or 4 as well. Like you can visit to any cell in this row. So in this row, you can visit to 3, and in this column, you can visit to 4 because both have greater value than 1. Now, if you visit to 3, we already know that from 3 you can't visit to any other cell. We have seen that previously. So if you take this path, number of cells that you are visiting is 2. Now, if you take another path, that is, if you start from 1 and you go to 4, in that case as well, number of cells that you are visiting is 2, because from 4 you can't visit to any other cell because 4 is the largest value in this particular matrix. So in the best case, you are able to visit 2 cells, and hence the answer here is 2, right? Let's take one more example. Let's say the matrix is 316 minus 9 5 and 7. So they're saying that the best path is if you start from minus 9. If you start from minus 9 and follow this path, like minus 9 to 3, 3 to 6, 6 to 7, that is the best possible path, and in this case you are visiting 4 cells. Notice that from minus 9 you can go to 5 as well, because like 5 is also greater than minus 9 and they both are in the same row. And from 5 you can go to 6 7 as well. But then the number of cells that you are visiting is 3, which is smaller than the maximum possible. So because 4 is the maximum possible cells you can visit, the answer here is 4. So hope the problem statement is clear. Now how to solve this? As always, let's start with the brute force solution. If you haven't thought about the brute force solution yet, I would strongly encourage you to pause the video and try to think about that for a moment. So what exactly we need to find? We need to say, okay, if I start from any cell x comma y, what is the maximum number of cells I can visit from there, right? So let's say x comma y is this 0 comma 0, and we are saying, okay, what is the maximum number of cells I can visit if I start from 1? So from 1 you can transition to 2, right? Because they both are in the same row and the value of 2 is greater than 1. Similarly, from 1 you can transition to 3 as well, right? From 1 you can transition to 7. You can also transition to 4, and finally you can also transition to 8 as well, right? So all these things you can transition to starting from 1. Now let's say you selected this particular transition first. So you are saying that from 1 I am going to 2. So what exactly you want from 2? You want that, okay, find me the best or the maximum number of cells that can be visited starting from 2. Isn't this problem exactly similar to the original problem? Original problem was find me the number of cells that I can visit, or maximum number of cells I can visit if I start from this particular one. Now we are saying that find me the maximum number of cells that I can visit if I start from this particular 2. So hope you can see the recursion here. The current problem is just is just similar to the original problem, and we can solve that using recursion. Now, one more thing before you can apply recursion in any question is there should not be a cycle in the state transitions, right? If there is a cycle, the recursion will get into an infinite loop forever and you will not get any answer. So in this case, there is no cycle at all. Why? Because every transition you are making sure that you are making the transition to something which is greater. So from 1 you are making the transition to 2, and 2 is greater than 1, right? So from 2 you will never get back to the original cell, right? So if you are making a transition, it is certain that you are visiting to a new cell always, right? And there are at most like n cross m cells, and hence this transition, like number of states will be finite and number of transitions will always be finite, and hence recursion would work here, right? So what will be the recursive formula for this? If you start from any cell x comma y, you can transition to uh, any cell which are in the same row and has value greater than the current cell. So for all this transition, you will try to find out what are their values. So let's say if you transition to 2, 2 returns R1, that okay, you can like if you start from 2, maximum R1 number of cells you can visit starting from 2. Similarly, from 3, let's say you return like you have value R2. Similarly, from 7 you have value, let's say C1, you have C2, and you have C3. So what you will do, you will simply take the maximum across all these transitions, and that will be the answer for your initial state 1, right? So let's look at the pseudocode for this. The pseudocode would be exactly similar to what we just discussed. We will, for any cell x comma y, we just write a function that will give us the maximum number of cells that can be visited if I start from cell x comma y. Now we will visit every row that is possible. Now all the possible rows are like, the condition is the value should always be greater than the value of the current cell, right? So if it is there, you can visit that row, and you are saying that from x comma y you are transitioning to r comma y, and you can simply call the same function to get you the maximum number of cells that you can visit if you start from r comma y. Whatever value you will get, you will add +1, because you like apart from all these cells you have already visited x comma y. So this would be your final result if you transition to r comma y. So you will try every possible value of r here and get the maximum result out of it. Similarly, you will try every possible transition to x comma c and see what is the maximum result you are getting. And finally, this result variable will contain the maximum number of cells that you can visit if you are starting from this particular cell, right? Now, what is the time complexity of this entire solution? So to calculate time complexity, we need to, like, firstly recursion, like if you build out the tree and if you try to calculate every state for every value, the time complexity would be exponential. But we can simply reduce it to a linear time complexity by just memoizing it. Basically, we'll say, okay, we'll not calculate same state again and again, and we will just store the value of a state after we have calculated it. So what we will say is we will store the value after we have calculated it, and we will use that to return the answer if it is the if we have already calculated it previously, right? So basically from this, the time complexity will be reduced to something exponential to some linear time complexity. So this is simple memorization. So let's just move forward. Let's say you have done this, and now what is the time complexity? So you know that there are, like, for a single state you are computing this algorithm only once, right? So how many states are there? Total number of states that are there is n cross m, right? N- that many number of states are there. Now for each state, what you're doing, you are iterating over every row and every column, and inside that you are doing some constant time operations. So basically for each state you are doing n plus m operations, right? So you are iterating over every row and every column. So this is the time complexity of the current solution, right? Now, surely this will not work because n cross m itself is 10 to the power 5, and if you add a factor of m plus n, it is 10 to the power 5 into 10 to the power 5, which will not pass. So we have to optimize this. Now, how to optimize this? Note like we have discussed this previously as well. Whenever you have a recursive solution and you want to optimize it, best is to convert it to an iterative solution and then try to optimize, right? So in this case, this recursive solution is nothing but the top-down solution of this problem. So what we can do is we can simply try to convert this top-down solution into a bottom-up solution, and we'll then try to optimize it from there, right? Because optimizing recursive solution is always hard uh, than optimizing the iterative solution, right? So let now the motive is to convert this recursive or the top-down approach to a bottom-up approach. Now for bottom-up approach, what you will need is you need to find out a set of states in which you can transition and get the value one by one without actually calculating the previous state. So in other words, what we are saying is, let's say you have an array. Let's forget about this problem for a moment. Let's say you have an array, right? So and you want to calculate something, like you have written a recursive formula that okay, f of I would be equals to, let's say, uh, 1 plus f of I plus 1, right? So this is just example. Let's say you have written this simple recursive formula. Now uh, for this to work, you for f of I, you first need to calculate f of I plus 1, right? For f of I plus 1 you need to calculate f of I plus 2. Similarly for this one you have to calculate the next one. So basically the last one is the one for which you don't need to calculate anything and you already know the answer for last one, right? So when you are implementing bottom up, you will start from last, because what you want in bottom up is that you don't need to compute anything which is required at all. So if this is the recursive formula, you should already have the value of f of I plus 1 calculated, and then only you will not do recursion and you will do iteration, right? So you will start from the end, you will start from n, you will have the value of n, and then you will calculate the value of n minus 1. So for n minus 1 you will need the value of n minus 1 plus 1, which is value of n, and you have already computed the value of n, so you can simply use that to calculate this value. Now once you have value of this, you can simply use to calculate this value, and so on and so forth, right? So the entire motive of explaining this is we need to first figure out what is the state for which we already know the answer, right? And if we figured out that state, then we will start from that state and move backwards to calculate the value of other states as well, right? So what is that, like what is the state for which you already know the answer in this particular problem? So I would encourage you to pause the video and try to think about it yourself first. So in this particular scenario, that state would be the one which have the maximum value in the matrix. So let's say in this case it is 9. So from 9 you can't visit any other cell at all, right? So for 9 you already know the answer. You know that from, if you are starting from the cell 9, the number of cells that you can visit is 1, right? So this is the first cell for which you already know the answer for. Now what is the second cell for which you know the answer? Second cell would be the second largest value. right? Because if you start, like let's say if you don't pick 8 and you pick let's say 5, so from 5 you can get to 6, or you can get to 7, or something else as well, right? But you don't know the answer for all the 6 and all the 7s yet. So that's where you will pick the one which is the next smaller, or in other words, in this particular scenario you will pick 8 and try to find the value of 8, right? Now once you have the value of all the 8s, you will find all the value like all the value for all the 7s, and then you will find the value of all the 6, and so on and so forth, right? So that is the like that is the order in which we are trying to iterate. And inside the iteration, we will just do exactly the same thing as we have done in the recursive solution. We don't need to modify anything here, right? So we'll start by sorting the cells by value, and then we will just copy paste whatever we have in this recursive solution. So the pseudo code for that would look something like this. So we will first sort by cells. So we maintained the rows and columns along with the value, and then sort the cells. Now we iterate from backward to forward because the last one will have the maximum value, and we want to start from there. So we'll start from, like for a particular cell, we x comma y, we know how to calculate its answer. We have already seen that here, right? So we'll just copy paste this entire thing here, right? Only thing that differs here is you are calling a function here, but now you are certain that the value of this cell r comma y will already be calculated, and hence you will simply use dp of r comma y, right? So there will be plus one here as well, but I think you get the idea. You you are traversing, or you're calculating each of the states in such a fashion that the next state that you will be needing is something which is already computed, and hence you don't need to call any function. You can simply use dp value here, and that should be sufficient. So this is the simple iterative approach, or the bottom up approach of the current top down solution. And this approach you can apply for any for converting any top down solution to a bottom up solution, and this should just work. Now we need to optimize this. Like our goal was to optimize the solution from n cross m into n plus m to something smaller. So we need to optimize this particular like bottom up solution. Let's forget about this top down solution now, right? So how to optimize this particular solution? So this the optimization of this is just based on one simple and straightforward observation. So I would strongly encourage you to pause the video and try to think at least for 5 to 10 minutes of how you can optimize this solution further. So hope you have thought about it. Now, how to optimize this? Firstly, do we need this condition at all? We don't, because we are certain that we are iterating over the cells in maximum to minimum order, right? And because that's the case, we can simply say that whatever cell we haven't yet visited is smaller than the current cell, and the value for that cell would be 0. So let's say there is a cell r comma y for which this condition is not satisfied. Or in other words, the value of r comma y is smaller than equals to the value of x comma y. So because the value is smaller, it means you haven't yet calculated the value of r comma y. So you can simply say that you can simply initialize the entire dp array with -1 or 0, like whatever value, whatever smaller value you can think of, and you can simply replace this if condition, because you know that all these r comma y's which are actually smaller, they their value would either be -1 or 0, whatever you have initialized with, and that value is smaller than any other value in the matrix. So we already know that the smallest value for a particular cell can be 1, and we are adding -1 or 0, and that would not make any sense, and the result would, the maximum will give you the, or maximum will skip that particular r comma y automatically, right? So what the new code would look like, we can simply remove uh, these two if conditions, and the new code would look something like this, right? Now still we just have removed a if condition, but the complexity is still order n cross m into n plus m, right? We still need optimization. So from here on, the optimization is all again a very simple step forward. Again, I would encourage you to pause and think by yourself first. So the next optimization could be, you can think of, look at this. What is this? This particular loop is just calculating the maximum value across a particular row, right? Or sorry, maximum value across a particular column. The column is fixed, column is y, and you want the maximum value across all the rows of that particular column. So basically you want the maximum value across a column, and similarly this for loop is calculating the maximum value across a row. So these two you can compute, pre-compute as well. Maximum value across a row or maximum value across a column is something that we can pre-compute very easily. And when we know the value of x and y, we can simply update the maximum value of row x and maximum value of row y, and that will give us the required result. So in other words, the current optimization is, now you will remove these two for loops with just a single variable access, smallest in the row x and smallest in the row in the column y. And these two arrays is something that you will keep on updating once you get the result for the current one. So you can simply say the current cell is x comma y, and the value of current cell is this result. So you can say the value or the maximum value of row x is result, and maximum value of column y is result. Now why I am not like, I am certain that result would be greater, because we already have taken the maximum across these two, and we are doing plus one as well. So we are certain that this value this value would be like, this result would be greater than both of this value, and we can simply override them without thinking much, right? So now the complexity is reduced to order n cross m, and that would surely pass. There is no issue with that. So it's not actually order n cross m, it is actually order n cross m into log n cross m, because we are actually sorting all the cells as well. So that sorting would take n log n time, and n here would be the number of cells, which is n cross m. Now this solution would pass. Now there is a small catch here that you need to take care of while implementing the solution. So let's try to do a dry run of this particular algorithm, and we will see what that catch is. So this was the solution that we have come up with. Now let's say this is the array. What this array is, basically we have sorted all the cells, so with the value. So we are saying that 9, which was at 0 comma 2, is the largest value. Then comes 8, which is at 1 comma 2, 1 comma 1, and so on and so forth, right? Now let's start with 9. So initially everything is minus 1, as we have discussed, because we like the entire entire base of removing this if condition was that we are visiting the cells in the sorted order, and hence if a cell is not yet visited, it means that cell is actually smaller, and we already have the value of that cell as minus 1 or something of that sort. So this max condition would not be polluted with that particular cell value, right? So let's initialize everything with minus 1 or 0. Like you can pick any one, but currently let's pick minus 1. So these are the values of max rows and max columns. Now, so this max rows and max column nothing but smallest in row and smallest in column, right? Now we'll start from the largest value, which is 9. So for 9, we already know the answer would be 1. So what like you will update the answer for max row of 0 to 1 and max column of 2 to 1. So you will say the answer here now is 1, right? And similarly, answer here now is 1, right? Let's move forward. Let's say you go to, sorry, uh, let's say you now go to 8. So for 8, you are at 1 comma 2. So you want the maximum value in row 1 and maximum value in column 2. So maximum value in row 1 is minus 1, maximum value in column 2 is 1. So you will say, okay, the maximum value that I will get at 1 comma 2, or maximum number of cells that I can visit if I start from 1 comma 2 is 2. So you got the answer 2 here. Now you will update the value of row 1 to 2 and column 2 to 2. So basically you will say this is now 2, and similarly this is now 2, right? Now let's move forward. Let's say you are at this 8 now. Now this is at 1 comma 1. Now again you will say what is the maximum value at row 1 and what is the maximum value at column 1. So at row 1 the maximum value is 1, sorry 2, and at column 1 the maximum value is minus 1, and the maximum of both of them is 2. So you will do 2 plus 1 and that would be the value here. So what this means? This means that if you start from 1 comma 1, you will be able to visit 3 cells. But this is not actually correct, because you are only allowed to visit cells which are greater. But here you kind of visited the cell which is equal to as well, and that's where you will get you have get this 3 as a result, right? So we have to skip visiting the cell which are equal to the current value, and hence we can't directly use this max rows and max columns in as is in the while calculating the value for this particular 8. Now think about it, what value you would want, or what max rows and max column value should be when you are calculating the value for 8. The value should be the one which we get after computing the result for 9, right? You would not want the value that you get after computing the result of 8 to be reflected in these two array, because you already know that uh, the value that got reflected after this operation would include 8 as well, but you want to exclude 8. So that's where you will work on the array that you have get after you have done the work for 9, right? So what exactly you will do? You will say that, okay, this was the value, this was the array when I have computed 9. So this was the array when this particular cell was completed. Now for all the 8s, I will use the same max rows and max column array, right? So let's just do that for now. Let's say you are at here now. So 1 comma 1, the maximum value of 1 is minus 1, maximum value of 1 here is minus 1. So it means if you start at 1 comma 1, you will be able to visit only one cell, right? So let's move forward for this one, 1 comma 0. So the value at 1 is minus 1, the value at 0 again minus 1. So the maximum number of cells that you can visit is 1. Like minus 1 plus 1 will be 0, and 0 max of max of them is minus 1, and that plus 1 is 0, like will give you the answer. So basically in the contest I have used 0, so 0 plus 1 gives me the answer, but in this particular scenario you just have to add one more if condition here, saying that if the max is minus 1, I would override this with 1, right? So that's just implementation details. So now you calculated the value for 8, you will want the value for this one. So again 2 comma 0, at 2 you have minus 1, at 0 you have minus 1, again this would be 1. And finally the last 8, 2 comma 2. So at 2 there is minus 1, at 1 at 2 this is 1, so value here would be 2, right? Now you want to compute the value of 3. So for 3, you would want everything to be there, right? You only want that 3 should not be there, but you want everything to be there. But what you have currently, we just have the array that only includes the contribution of 9. That doesn't include the contribution of any of these 8s, right? Notice that there are two 8s which have value 2, and this can help this 3 as well to get a larger value. So we need to now, like once we have transitioned to 3, then only we will merge the contribution of all of this. So we will simply reiterate over this entire like values of 8, and now we will just do the recomputation of each of the values. So the value at 1 comma 2 was 2, so you will say okay, you will apply these two things now. So you will say maximum of at 1 the value was -1, so let's just update this to 2, right? Similarly at 2 the value was 1, so let's just update this to 2. And now we will go to 1 comma 1. Again 1 comma 1 has 1, so the value at 1 is 2, which is already greater than 1, so that is good. Now the value here at 1 is -1, so which is smaller than 1, so you will simply update this to 1, right? Now in the same fashion you will go forward, and you will see that finally you will just update, like the values will be updated to this particular thing, right? And now for 3 you will use these two max rows and max column array, right? So hope this particular thing makes sense. So the only thing that you need to take care while implementing this particular algorithm is you will be visiting, or you will be doing this entire thing in a single shot for all the equal values. And once you have done that, then only you will iterate over all the equal values and do this particular thing. And now because you are doing them in a separate loops or in a separate fashion, the value result here can, like, may or may not be the greatest one. As we have seen here, like we want to update 1 to 1, but the 1 already had value 2, so the value may not be the greatest one. So this equals to result is something you have to replace with max of smallest in row comma result, right? So that's the entire algorithm. The complexity is still order n cross m into log n cross m, and there, like, you can just simply try to code this entire thing by yourself. So if you have watched till this point, I hope you now understand how to convert a top-down solution to a bottom-up solution without much thought, and then how to look for optimizations in the bottom-up solution itself, right? So if you have watched till this point, I would strongly encourage you to pause the video right away and try to code the solution by yourself and get it accepted as well. Next, we'll be looking at the code. So this is the first algorithm where we are updating everything after computing the value. So for example, like first we have calculated the cells. So cells array would just be the r comma c and matrix of r comma c, the value and the cell. So this cell contains three things: row, call, and value. And we just have, like, the operator less than is overridden to work with just value. So now we just sorted the cell, so it will sort by values, and we'll get the cells in smallest to largest. We will try to iterate over it from smallest to largest, and we have initialized our max rows and max columns with 0. Now inside this, as we already know that we need to keep maintaining, like we need to iterate over all the same value in a single shot before updating max rows and max columns. So what you could have done is you could have created a local max rows and max columns, and you could have updated that max rows and max columns while iterating over the values, right? Now after this entire thing is done, you could now say that okay, I will go over all the rows and all the columns and update the max rows and max columns now. Now this solution Like this is a valid solution, but this will not work because the complexity again, like you unknowingly bring the complexity from n cross m to n cross m cross n plus m, because you are now iterating over all the rows and all the columns. That's where it is very important to just iterate or reiterate over everything here, because if you reiterate over everything here, you already know which all rows and which all columns will be affected, and you will be affecting only those in this particular thing. So what you can simply do is you can simply modify that particular part either by using a map, or you can simply reiterate over everything, or like over every possible j, and make this particular update, right? So hope this entire solution makes sense. If you have any doubts in this particular problem or in any of the concepts explained in this problem, feel free to post them in the comment section below. I would be happy to answer. If you like the video, give it a thumbs up and do subscribe if you haven't already, and I will see you in the next one. Thank you.